Hello everybody, this is a very short video about congruence and using the modulo operator so that we are very clear about vocabulary. Here, let's A and B two integer numbers and let's make simple Euclidean division of A by B when you have some quotient Q and some remainder R. Then actually, if we mind only about the remainder, and you'll see that's something that will very often happen, especially when talking about the Z over NZ set. You'll see just later. Then you can write the following thing, that is A modulo B, which is a number, and actually you will get the remainder of the division of A by B. So as it is a remainder of the division, remember that we know that R will be greater than or equal to 0 and strictly less than B. So if you choose any number A and write A modulo B, this means that you want to get or you want to talk about the remainder of the Euclidean division of A by B. And this will lead you, after some calculations, to a number which is greater than or equal to 0 and strictly less than B. Now, second part about congruence. This is a notation that you also find in the document for the course. Actually, now let n be some integer numbers. We can also write some congruence relation between two numbers. So let also A and B be two integer numbers. Then we can write that A and B are congruent with respect to n, that is A congruent to B modulo n, which is equivalent to A minus B is a divisor of n, which is also equivalent to A and B have the same remainder by dividing by n. Okay, so let's make a quick proof of the fact that A minus B, the divisor of n, is equivalent to the fact that A and B have the same remainder by dividing by n. So, for example, let's divide A by n. We'll have a quotient QA and some remainder R. Let's divide B by n. We'll have another quotient QB, and the hypothesis is that the remainder is also n. So what we know is that A is QA times n plus R. B is QB times n plus R. So here, from those two equations, we have A minus B is QA minus QB times n plus r minus r. So actually, this is equal to 0. So now a minus b is some integer number times r. This means that actually a minus b is a divisor of n. So this is not very difficult, just to remember you that sometimes in the remaining of the course we can use the notation a modulo b or p modulo n. This will correspond to the remainder of the Euclidean division, and this notation with congruence, meaning that two numbers share some kind of property with respect to another number n, here for a and b. Actually, a is congruent to b modulo n, mean that a minus b is the divisor of n, or, and it's strictly equivalent, that a and b have the same remainder by dividing by n.